Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Welcome to gravity. Why does an apple fall down instead of flying upward? This is because of the force called gravity. You must know that gravity is a force that pulls objects towards each other. Everything in the universe has gravity. The earth, the sun, the apple, and even you. In the 1600s, an English physicist and mathematician named Isaac Newton was sitting under an apple tree, or so the legend tells us. Young Isaac was sitting in an apple orchard, and suddenly an apple fell on his head. He started wondering why the apple was attracted to the ground in the first place. Why do things always fall down and not up or even sideways? Newton was only 22 years old when he figured out that it was not an accident that the apple fell downward. It was the force of gravity. What Newton said about gravity and the way things move forever changed the way people think about the world. Every time you jump, you experience gravity. It pulls you back down to the ground. Without gravity, you would float off into the atmosphere, along with all the other matter on Earth. You see gravity at work anytime you drop a book, step on a scale, or toss a ball up in the air. It's such a constant presence in our lives, we seldom marvel at the mystery of it. But even with several well-received theories out there attempting to explain why a book falls to the ground at the same rate as a pebble or even a couch, they are still just theories. The mystery of gravity's pull is pretty much intact. So what do we know about gravity? We know that it causes any two objects in the universe to be drawn towards one another. We know that gravity helped to form the universe. It helps the moon in orbit around the Earth. We know that it could also be harnessed for everyday applications, like gravity-powered motors or gravity-powered lamps. As for the science behind the action, we know that Isaac Newton defined gravity as a force, one that attracts all objects to all other objects. Along with his 3 laws of motion, Newton's law of gravity explains all the motion we see in our universe. Remember that Isaac Newton realized that the same forces and the same laws of physics apply everywhere in the universe. So his law of gravity is also called the law of universal gravitation. Newton publicized his theory of universal gravitation in 1680s. You need to know that this law basically set forth the idea that gravity was a predictable force that acts on all matter in the universe, and it is a function of both mass and distance. The theory states that each particle of matter attracts every other particle. Gravity attracts all objects toward each other. So the farther apart the particles are, and or the less massive the particles, the less gravitational force. When you deal with massive bodies like Earth, you end up with a rather powerful gravitational force. That's why you're not floating around in space right now. On Earth, gravity keeps the air around us and everything else from drifting off into space. Gravity also causes things to fall to the ground, and it causes the ocean's tides, and it causes hot air to rise while colder air falls. You need to know this. The force of gravity acting on an object is also the object's weight. When you step on a scale, the scale reads how much gravity is acting on your body. Don't forget that an object's mass is not the same as an object's weight. Mass is the amount of matter or stuff in an object. Weight is a measure of gravitational pull on an object. On the moon, an object will weigh 1/6 the amount that it would weigh on Earth. Since the moon is 1/6 the size of Earth, it applies less gravitational pull. Gravity keeps the moon orbiting around the Earth. Gravity also keeps the Earth orbiting around the sun. Gravity even holds the planets and stars together. Gravity is one of the most important forces in the universe. Without it, we wouldn't even have a planet to stand on. We wouldn't be able to experience high tides or low tides. We wouldn't be able to walk or to run. You need to know that tides are created by the gravitational force between the Earth, the sun, and the moon applied to our oceans. As the Earth spins on its axis, one part of it faces the moon. Because this portion of the Earth is the closest, the gravitational force is the strongest on that portion of the Earth. Oceans on the moon-facing part of the Earth are drawn towards the moon. This creates a high tide. Inversely, the parts of the Earth that are not facing the moon are experiencing low tides. You must remember that the acceleration due to gravity on Earth is 9.8 meters per second squared. It never changes, regardless of an object's mass. That's why if you were to drop a pebble, a book, or a pencil off a desk, they would hit the ground at the same time. When you drop a ball from a building, not counting friction created by air, it will go faster by 9.8 meters per second for every second that it falls. If it begins at 0 meters per second after 1 second, the ball will be going 9.8 meters per second. And after 2 seconds, it will be going 19.6 meters per second. And after 3 seconds, it will be going 29.4 meters per second, and so on. Remember this, the force of gravity between two objects depends on the masses of the two objects and the distance between the two objects. The greater the masses of the objects, the greater the gravitational force between the two objects. Finding the gravitational force between two objects requires multiplying the masses of the two objects. Write this down. Increasing the mass increases the gravitational force between two objects. Decreasing their mass decreases the gravitational force. Why don't we fall toward the people next to us if every object has a gravitational pull? Since people are much less massive than Earth, the gravitational pull that they exert cannot be felt. If the sun is more massive than the Earth, why don't we fall toward the sun? We don't fall toward the sun because the sun is much further away. You must remember that as the distance between two objects gets larger, the gravitational force between them gets weaker. As the distance between two objects gets larger, the gravitational force between them gets smaller. It never gets to zero. It just gets too small to matter. If you were suddenly suspended in space, twice as far from the center of the Earth as you are now, the gravitational force would be 1/4 as much as it is on Earth's surface. If you weigh 100 pounds, you would suddenly weigh 25 pounds. No matter how far you get from Earth, there's still some gravitational force. Write this down. All objects fall at the same rate of acceleration. the gravitational force that the Earth applies to all objects is constant. Gravity is the attractive force between two objects. But what is the relationship between mass, weight, and gravity? Don't forget that the mass is a measure of how much matter an object contains. It is measured in grams, and it stays constant no matter where it is in the universe. Weight, on the other hand, is a measure of the gravity's effect on an object. It is measured in newtons and varies depending on where in space an object is. For example, your mass is the same on Earth as it is on the moon. But since the moon has only 1/6 the mass of the Earth, meaning that its gravity is just 1/6 as strong, you will only weigh 1/6 as much on the moon as you do on Earth. Since Jupiter is the most massive planet, you would weigh more on Jupiter than you would weigh on Earth. Why is that? You would weigh more on Jupiter than you would on Earth because Jupiter is much more massive than the Earth, and therefore it applies a much greater gravitational pull on your body, resulting in a greater measurement of weight. Gravity is the natural force that pulls everything down to the ground. What better way to show you this idea is to show you what happens when I let go of this cup. Any guesses? Oh yeah, that's right, down to the ground. That is the thing about gravity. It's always there. It doesn't matter if it's a delicious cake or these plastic glasses. When I was pushing them off the counter, they go right down to the floor, thanks to the force called gravity. Okay, you can't see it, but it's always there. Gravity, it keeps you and me from flying off into space.
Thank you for joining us on how to improve science performance through strategic note-taking.